Hello everyone, welcome back to the Atharva Gate Academy. In previous video, we have discussed about the bending stress, bending equation and we have seen some example related to bending stress. In this video, we are going to start with the torsional stress and later on we will see torsional equation. When we apply twisting moment in any body, then the shear stress is produced and that shear stress is called as torsional stress because that stress is parallel to the cross section. Okay, now let's say we have this cylindrical rod and the cross section of this cylinder is circular as shown here. We fix this cylinder from the left surface and on the right side we apply twisting moment T in the clockwise direction when we see from this side. Let's say this is the side view of this body when we see from this side. Then what will be the twisting moment? Twisting moment will be in this direction. If we want to show this twisting moment T on this surface, then we can show it like this. Here there will be the centroidal axis of this body. This axis is called as neutral axis. Let's say this is the center of this body. Here there will be the centroid of body. Here this body will be in equilibrium and we apply the twisting moment T in clockwise direction. So there will be a reaction at this surface. It will be in anti-clockwise direction and it will also have same value T. Now what will happen to this body when we apply twisting moment T? Let's say before applying the twisting moment T, this point is A. Now when we apply twisting moment T, then this body is going to be rotate about this point, or we can say about this centroidal axis or neutral axis. So this point A may be displaced at this point. Means there will be an angular displacement of this point. Means after applying the twisting moment T, this point A will displaced to this point, let's say A dash. If we consider this point as O, then there will be the angle between OA line and OA dash line. This will be the OA line and this will be the OA dash line. So let's say this angle is theta. Here this theta is called as angle of twist. We can also say that theta is the angular displacement of the A point. Now when we apply twisting moment T on the body, torsional stress will be produced in this body, right? Now let's say R is the radius of shaft, or we can say radius of this body. T is the torque or twisting moment applied in this body. J is the polar moment of inertia. G is the modulus of rigidity, theta is the angle of twist and L is the length of shaft, or we can say length of this body L. Now here is the torsion equation that we can derive from this condition. But here we are not going to derive this equation because as we know, derivation of the formula, or we can say equation, is not important in the GATE. You only need to remember this equation. If you want derivation of this equation, then you can refer any good book. You will find it easily. Okay. Now in this equation, tau by R is equal to T by J is equal to G theta by L. I think you are aware of all this term, right? But maybe you are not aware of the polar moment of inertia. If you are not, then don't worry, we will discuss it in the engineering mechanics subject. Right now, you just remember that polar moment of inertia for circular body is pi by 32 d raised to 4. This polar moment of inertia is about the centroidal axis of this body. There are so many questions have been asked from this equation. Some values will be given to you and one value you have to find out from this equation. So you can find out that value by comparing any two of these. You can compare first and second term, second and third term, and first and third term. Okay. Let's say if we compare first two terms, then what will be tau? Tau will be T into R divided by J, right? Now if we put value of J from here, then it will be T into R divided by pi by 32 into d raised to 4. Here radius is equal to diameter by 2, right? So we can write d by 2 instead of R. So finally, what will be tau? Tau will be equal to 16t divided by pi d cube. Here t is the twisting moment, or we can say torque, d is the diameter of cylindrical body, and tau is the torsional stress produced in the body. Now let's say here if we compare second two term and we want to find out angle of twist, then theta will be equal to T into L divided by J into G. GATE may also ask question from this equation. It may ask to find angle of twist. In the equation, value of T will be given, L will be given, G will be given, and diameter will be given. So we can find J is equal to pi by 32 d raised to 4, right? So by putting this value, we can find theta. Now let us talk about units of each and every term. You should take unit of this torsional stress in megapascal, radius should be in mm, twisting moment or we can say torque should be in Newton into mm. This polar moment of inertia should be in mm raised to 4. Modulus of rigidity, or we can also say that shear modulus, should be in megapascal. This theta should be in radian and length should be in mm. If we use these units in this equation, then we can solve question very fast and easily. So I prefer you to use these units. If any value of this is given in any another unit, then you have to convert that unit into these given units. Okay? Now let's say in this case we want to find out stress diagram in this body. We know the equation that tau by R is equal to T by J. Here R is the radius at which we want to find out torsional stress. Value of T and J is fixed, only R may be vary. If we want to find out shear stress at this point, then we have to take R is equal to this radius, means it is capital R. Let's say if we want to find out shear stress at this point, then we have to take this radius, let's say it is R instead of capital R. And if we want to find out shear stress at this point on the neutral axis, then we have to take radius R is equal to 0. So if we put R is equal to 0 here, then what will be the shear stress? Shear stress will be 0. So at this point, or we can say at neutral axis, value of shear stress will be 0. And value of shear stress will be maximum at the outermost surface, because at the outermost surface value of R is maximum. Here we can say that shear stress is varying linearly with the radius R. Let's say we want to do shear stress diagram at particularly this cross section, then what it would be? At the uppermost surface it will be in this direction and it will be maximum, right? And from this point to this point it is varying linearly, so it will be like this. Here at this point shear stress will be this, and at this point shear stress will be this. At this cross section shear stress will be in this direction and it will also vary linearly like this, right? At this cross section it will be in this direction and it will also vary linearly, and at this cross section it will be in this direction and it will also vary linearly. So this is the shear stress diagram at any circular cross section of this body, right? Now here you can see that this shear stress is parallel to the circular cross section of this body. So we can say that this stress is parallel to the circular cross section of this body. And we know that stress which is parallel to the cross section is called as shear stress. So we can say that torsional stress is actually shear stress. Now let us understand what is the meaning of pure torsion. We know that torsional stress is equal to shear stress, right? So pure torsion means there is only shear stress produced in the body. There is no any normal stress produced in the body. When we apply twisting moment as shown in the figure, then in that case there is only shear stress in the body, and that case is called as case of pure torsion. Okay? We have discussed strength criteria and rigidity criteria in bending. Now we will discuss strength criteria and rigidity criteria for torsion. First of all, we will discuss design based on strength criteria. In strength criteria, tau induced should be less than or equal to tau allowable. Means shear stress produced in body should be less than or equal to allowable shear stress. Now we know that tau by R is equal to T by J, right? So from here we can find out tau induced. So tau induced will be equal to T into R divided by J. Now how to find out allowable shear stress? Allowable shear stress is equal to strength of yielding in shear divided by factor of safety. Here SYS means strength of yielding in shear of any material is the maximum value of shear stress that the material can withstand. And we can also say that SYS is failure stress in shear. We have already discussed factor of safety in bending, right? In bending case, we take here failure stress, right? In bending, we can also say that sigma allowable is equal to strength of yielding in tension divided by factor of safety. You can write it down in the notes, okay? In bending, SYT means maximum value of stress that material can withstand in the tensile loading. You should know that allowable stress is also called as permissible stress. Now here Zp is the ratio of J by R. Zp is called as polar section modulus. So if we put Zp instead of J by R, so it will be tau induced is equal to R divided by Zp. Now tau induced should be less than or equal to tau allowable. So this term should be less than or equal to tau allowable. So we can write that Zp should be greater than or equal to R divided by tau allowable. So for safe design, value of Zp should be greater than or equal to R divided by tau allowable. Okay? This is all about the strength criteria. Now we will discuss rigidity criteria. Design based on rigidity criteria. So in the rigidity criteria, theta induced should be less than or equal to theta allowable. What is theta? Theta is the angle of twist of body, or we can say angular displacement of the body. Now what is theta induced here? We know that T by J is equal to G theta by L. Here this theta is theta induced. So here theta induced will be equal to TL by GJ. As per the rigidity criteria, theta induced means TL by GJ should be less than or equal to theta allowable. Now if you remember, in bending we call EI as the flexural rigidity. In torsion, GJ is called as torsional rigidity. So in the question, if torsional rigidity is given, then we should understand that value of G into J is given. Okay, so remember this and also remember this formula. This is all about rigidity criteria. Now today we will stop here and continue in the next video. Till then, remember the equation and revise the notes. Okay, thank you for watching.